Welcome everyone to today's webinar, Creating Knowledge Workers for the Greener Product Marketplace, Part 14, talking about hands-on training in lifecycle thinking and LCA for executives. And we are honored to have with us today as our special guest, Thomas Kwan from Yale University, who's going to share a recap of the story that he told last year on one of our previous webinars in this series, which is not only a great story to share with educators, but now really important to be sharing with executives in industry. Just to let you know, the webinar is being recorded and we will post it. You will be able to request the webinar deck if you would like, and we'll let you know what possible next steps are available to you if you feel that what we're doing is relevant to you, and we really look forward to connecting with you afterwards. So here's our agenda for today. I'm going to give you a background on Sustainable Minds and our Eco-concept and LCA software, which will segue then into Thomas's presentation about his course at Yale. Then I'll come back to talking about the use cases that our software is used for in industry. And then we'll talk about the services that we offer to support what you're hoping to learn about today. And we'll do some Q&A. Also with me on the call listening in is Peter Steele, our head of our Eco-concept and LCA software sales. He'll be moderating the Q&A at the end. And please put your questions into the questions panel. We'll work to get to those. And if we don't get to those, we will certainly follow up with you. There's opportunity to leave questions and a couple poll questions at the end. We hope you'll take the time to respond to, but also to leave your own thoughts as well. So, and welcome, Thomas. So quick background on Sustainable Minds. Some of you who are attending know us from our software products, and some of you who are on know us from our transparency reporting products. We have two product families. I'm going to bring this story together starting now, and we're going to reconnect it again in a little bit. That we are a mission-based company. I'm Terry Swack, the founder and CEO of Sustainable Minds. I founded the company 10 years ago with a mission to operationalize environmental performance into mainstream manufacturing to drive revenue and growth through greener product innovation. And our mission has never changed. The first part, when we launched with our Eco-concept and LCA software, which was to help product manufacturers come together around a common mindset, which is why we named the company Sustainable Minds. You have to get people to think the same way to get them to act the same way. And what you're going to see is getting them to think the same way is getting them to think from a life cycle perspective, a full life cycle perspective. When I started the company 10 years ago, the software category, PLM, product lifecycle management, people in manufacturing thought about the product lifecycle as cradle to gate. And once the product left the manufacturer's shipping dock, no more responsibility. And frankly, product development really wasn't done thinking about the full life cycle. And that's what we're going to talk about today. And that's what we've been helping people think about and learn and integrate into the way they make products, and the way they educate students is to think from a whole life cycle perspective. And I'm going to regroup on this slide a little bit later, where we've started out helping manufacturers design greener products, and then with the advent of LEED version 4 and the adoption of life cycle thinking and reporting in the green building industry, we developed our second product family, our transparency products, to help manufacturers market those greener products. And the point that we want to make and that we want to help manufacturers actually integrate and execute is this continuous improvement loop of actually making higher performing, greener products, and then having meaningful stories to tell in the marketplace when and if, as a manufacturer, you decide to produce product transparency disclosures. So since we launched the company and brought this software to market, we've been really honored to have got the traction that we have in the industry and built this global brand. In the early days of the company, we focused primarily on getting the software used in manufacturing and consulting. And we saw this kind of viral adoption in higher education, business design, and engineering at every level. You'll hear from Thomas teaching in the executive MBA program, in graduate schools, undergraduate schools. And over time, we shifted our focus to the education space because, quite honestly, 2009, 2010, 2011, manufacturers were still not that interested in figuring out how to integrate lifecycle thinking into product development. So now, fast forward another 7, 8 years, the market has really changed, and there now is no doubt that manufacturers really do have to think differently about the way they make products. There is no possibility to do things the way we used to, and people are looking for solutions, how to get started. And so that's what this is all about today. Usually this webinar, most of the content, the title is Getting Started. And so we've integrated our Getting Started webinar with our Creating Knowledge Workers webinar series to bring it together for you today. And so again, here's our mission. It's not about, I'm using air quotes, it's not about doing the right thing. It's really about helping manufacturers grow through integrating greener product innovation. And it has to be done in 2 parts. You have to teach people to think differently, and that's the eco-design component, and you'll see we've turned that into eco-concept modeling. And then lifecycle assessment. You have to teach people to think differently and measure, because if you just think differently and you don't measure, you don't know if your new ideas are actually making any kind of meaningful performance improvement. And if you only measure without thinking differently, the likelihood of getting any kind of innovation or dramatic performance improvement is less likely because measurement really only gets you incremental change. And so when you think differently and measure, thinking differently is where the innovation happens, and that's how you're going to get to truly greener products. So green is a code word for environmental performance, and I'm going to use those terms interchangeably. Environmental performance over the last decade has been the new and emerging criteria in product development that sits alongside all the traditional criteria: functional performance, cost, aesthetics, safety. And today it really is a business driver. There's real demand for products with higher environmental performance. And there's industry drivers as well as internal drivers: the cost for natural resources, regulation, rating systems, supply chain risk. This is a iconic image of a doll from Mattel. You may remember some years ago that created a big scandal that Barbie had lead paint because of a supplier in China. These are all external drivers, and the internal drivers really have to do with building a brand, looking for innovative products that can be distinctive in the marketplace, and then the new markets and new revenues that you're going to get from those new innovative products. And don't be confused. I think the old mantra used to be, oh, green is more expensive. Well, actually, it's the opposite. Where there are environmental impacts in the system, there are costs. When you can reduce environmental impacts, or conversely, increase environmental performance, there should be lower costs, there should be increased revenues, and companies who really are committed to making that a goal will achieve a competitive advantage. But it does require new knowledge, new processes, and new tools. So when we brought our software to market, we were really focused on this problem, which is that lifecycle assessment was normally used after a project or a product had been manufactured, which is too late, really too late to make any changes. And by the time changes might get made in that product again, some number of years may have gone by, and that data hasn't necessarily been brought around to the front of the process. So, here's the opportunity to bring lifecycle thinking and LCA into early stage product development. And the reason to do it is that once you get out of concept design and into detailed design, 75% of your manufacturing costs are already committed, because you're making the decisions about materials, energy requirements, recyclability, the lifetime of the product, and all of those things get locked in. And as you all know, making changes once you get into detailed design are very costly and hard to do. And further, there are many, many, many more people involved in making decisions about products today than there were 10 years ago. You've got business people, supply chain people, procurement people, design people, engineering people, all across the organization. And what needs to happen today is everybody needs to adopt the life cycle perspective. And those of you who have been involved in higher performance product development or environmental reporting know the challenges of trying to educate procurement folks, suppliers, about why it's important. This is really now going holistically. Look, we have to get everybody on the same page. They have to understand why it's important to think and work this way, and everybody has their role to play in changing the way products get made. So talking about eco-design is the practice, the methodology of looking at design strategies and business and design and manufacturing strategies that can be considered in each stage of the product's life cycle. So when you break the life cycle down into, as we had on this previous page, raw material acquisition, material manufacture, product manufacture, transportation and distribution, use, and end of life, and you've got transportation and distribution between each of those stages, and certainly you've got end of life back into manufacture. There are strategies that can be applied in each of those life cycle stages to drive innovative thinking in terms of where can performance improvements be made. And any good strategy framework can also be used as an analysis framework. I think Thomas might actually talk about this, but this is one of the exercises that we teach in the training. It's also in the Learning Center, that you can use that eco-design strategy wheel to analyze products that are in the market with very little information about those products. You can begin to imagine, by applying this wheel, what the manufacturer has done to improve those products. And where innovation reliably happens is when multiple strategies are used in multiple life cycle stages. Lifecycle assessment, most of you are familiar with it. It's both objective and comprehensive. It's done according to a library of ISO standards, but keeping in mind it's done to be an investigative assessment, that there's iteration between every step in the process, and it can be used for lots and lots of purposes, not just for reporting. Its intent originally was to be used for expressly this, to analyze and understand what's happening in the life cycle of a product system and ultimately be able to drive improvements and then report. This is probably the most technical slide I'm going to cover in my portion of the presentation. And this is the challenge that we faced as a software company, was how to simplify this very technical field of lifecycle assessment to make easy to use tools that non-LCA experts would be able to use. And so what we've done here is tried to integrate LCA terminology with product manufacturing terminology. And so this slide shows how to translate a bill of materials, so manufacturing terminology, into environmental impacts. So we coined this term a system bill of materials, meaning all the inputs from the product system or the product life cycle. And when all of those inputs are turned into what's called lifecycle inventory data or process inventory data, all of these inputs can be described by their chemical composition. And then each of those chemicals, when put through an assessment methodology, can be attributed to one or more types of impact, either to human health or to the built or natural environment. These are called midpoint, these are endpoint impacts. And so we've made a simplified system that allows product teams, whether they're business people, design people, engineering people, it's better when it's a mixture of all of those people to get everybody thinking and collaborating the same way. First, to understand there is no such thing as a green product. Green is a relative value. Again, we're talking about environmental performance. Something can only be better than something else. So at the core of our software is this ability to create a baseline or a reference model, and then to rapidly be able to create comparative or competing concepts. And what's the most important is understanding the performance improvement or the increase in impacts of the concepts that are being investigated, and using the eco-design strategies to drive the creation of the new concept, to understand which of those strategies or which combinations of strategies are ultimately getting you directionally correct improvements. The other thing that's really important to emphasize is that lifecycle assessment, when done for external reporting, is an extremely explicit process. Every single thing that goes into the product system needs to be documented and actual data acquired. When you're working on modeling concepts in early stage design, by definition, concepts are loosely defined and rapidly changing. And so you need a tool that allows you to answer little questions. Is a material better or worse? But also a simple tool to answer more complex questions. Where in the product system, if I look at everything, are the impacts are occurring? Where can I apply strategies to change it up? And so our software can be used to solve or answer really simple questions or more complex questions in a not so explicit way. So what we've developed and are offering is the ability to do eco-concept modeling with real-time LCA results. And so you'll see, as Thomas gets into his presentation, the key tenets in the software, the ability to compare, understand the impacts, and we've also built in a learning center, which has an extensive user guide and is literally the equivalent of about a 150-page textbook on LCA and eco-design. Our single-figure score methodology is a recipe that integrates lifecycle inventory data from trusted sources. It's mostly from EcoInvent and NREL and other other technical sources. Our methodology is Tracy, and we used a normalization and weighting schema developed at NIST to take these 10 impact categories and turn them into a single figure score. We also pull out the carbon equivalent, so you get 2 scores. The carbon equivalent score is an actual value, and the impact factor score is this aggregated value. And you can benchmark and compare, get quantified estimates for non-experts in a standardized way, and it's easy to share and interpret results. The real point, and most of you on the call are really always looking, and you have to make the business case, the ROI on doing life cycle thinking and life cycle assessment is that innovation isn't safe, it's risky. And you have to have real data up front to be able to make those informed decisions. And value can be measured either through cost savings or return on investment can be measured through cost savings or value creation. And each organization has to decide which of these ROI metrics are most important and how they're going to be measured to be able to make that business case. So to close the loop, manufacturers have 2 key problems. Not only do they need and want to design greener products, but they need and want to market those greener products. And it's the very, very same drivers that are driving the market greener product, with this emphasis on brand, that creating a credibly greener brand means that as a manufacturer, you have to be able to demonstrate that you really know what you're doing and be able to tell those stories in a meaningful and credible way and link those stories to the technical results that you're disclosing to the marketplace. And it was that idea, that thinking, that has driven our product development around that continuous improvement loop of designing and marketing. So now I want to turn it over to Thomas to take you through his course at Yale in helping bring product executives into this world of lifecycle thinking and LCA. So Thomas, take it away.
All right, thank you, Terry. And I'm very excited to share with our attendees our approach to incorporating lifecycle thinking in product design for executives. So before I start, a little bit about me, which can give you some context on our approach here at Yale for incorporating LCAs in our classes. I have advanced degrees in environmental and chemical engineering. I'm currently at the Center for Green Chemistry and Green Engineering at Yale. I instruct a couple of courses. One is a multidisciplinary engineering course, and it's centered around product design. And this class is great because we utilize a makerspace. So Yale has a makerspace, which essentially has equipment to take somebody's idea from concept all the way to a prototype, and then even further to possibly even spin out companies. So there's things like 3D printers, laser cutters, simple scissors and markers, crayons, textiles. So any kind of hands-on equipment that you would need to make a prototype or design something is in this center. And this is where we hold our class. There's a lot of movement towards in the maker space. We call it the National Maker Movement. And in 2016, I was invited to go to the White House to talk about this maker movement and some of the best practices for micro manufacturing and how to do product design. And there is, like I said, a lot of momentum in this area, but one thing that's lacking is the incorporation of life cycle thinking in micro manufacturing. And this is where my specialty comes into play. We've incorporated Sustainable Minds in our classes so that as our students, as our MBA students think about what a product is, they're using the software to guide their design, and they really use it to catalyze their innovation. So here is our wonderful new Yale School of Management building. I always like to show off this picture. It looks like a big airport, if you ask me, but it's a wonderful new facility. And in this facility houses the EMBA program. A little bit about that, it's a 2-year program, and it's for working executives. There are 3 focuses. One is asset management, one is healthcare, and then the third is sustainability, which is the focus where our class is held. In the second year, the students take kind of deep dive classes with experts, and this is where my class is held in the second year. The class is called Sustainable Design and Innovation, and the idea is to give EMBA students some hands-on experiential learning of taking product design from concept to prototype to pitch. And along this way, we set them up with a couple different kind of canned products, or I'm sorry, canned exercises. And then at the end, we ask them to design something from scratch, from concept, and then to build a prototype, and then to pitch it to us. And we do this in a very rapid fashion. All along the way, they're using LCA software, the Sustainable Minds software, to guide their decisions so that they can understand the environmental impact that their design has. This is a picture of our makerspace where our class is held. It's wonderful. Most of the engineering students that I have for the engineering class are very comfortable in here, but oftentimes when the MBA students first walk in, it can be a little unsettling for them because it's very unfamiliar. But they tend to aggregate very quickly, and they really enjoyed this space. So this is all about giving people experiential learning, hands-on activities, so that they can really understand to think about a life cycle design and life cycle thinking. All right, so for the EMBA class, the goals, like I said, is to design a product. And we say a sustainable product because that's a very common language for people to really understand. But what we really ask our students to do is to design better products for the market, for function, for service. Just we want better products. And as a consequence of having life cycle thinking, they will be greener. We also ask them to justify or to invalidate why a product would be sustainable or not. All right, so for some of the exercises that we have the class do, there are 3 projects. The first 2, like I said, are canned or contrived case studies in which they use Sustainable Minds to perform LCAs, and then they recommend products. And then the third one is actually doing the product design with the LCAs and then building their prototype in the makerspace and then pitching it to the class and to experts. So I'm going to take you through the 3 cases that we used in the class. The first one, oh, and I should mention that these first 2 kind of preset case studies that they did LCAs on are based off of Sustainable Minds training material that they have. We took that and then we added some complexity to it, and we changed some of the values to hit some of the learning outcomes that we were trying to have the students get. So the first one is about hospital gowns, and we provided, I think, 4 different hospital gowns, and we provided some context on the actual gown itself and the company, as well as we generated some context about the actual hospital that would buy or purchase these hospital gowns. This first exercise was really about getting the students to jump in to Sustainable Minds and use the software, but at the same time understand what the sustainable or the LCA results mean in context to the system. So some of the students really understood that the values for the LCA have broader context. And so what I mean by this is that in all the case studies that we gave them, the hospital said that it was paramount that the hospital gowns were comfortable for the doctors, otherwise the doctors would not use them. And in the different gowns that we had them do LCAs on, only one of them was rated comfortable for the doctors, but didn't necessarily perform the best in terms of the LCA performance, in terms of the CO2 equivalence or the environmental impact. So this kind of served as a purpose to say LCA is a tool and it's a way to think about your products, but part of that thinking is in what is needed from the company and what the users are expecting in terms of function and performance. So this is a snapshot from one of the students' results. And you see here at the bottom, it says, however, the task force did not contemplate the functional needs of the doctors. And these robes were designed by a fashion house, and it didn't really fit what the doctors were looking for. So we asked the EMBAs to give a recommendation on which gowns they would recommend. Some went just solely by the LCA results, and some went by incorporating the LCA results into the context of what was needed in terms of function and design for the doctors. So there's some trade-offs, right? So this first exercise was to really get the students just to jump into the software and then to think about how LCA results fit in to what they are analyzing. So the students quickly find out that Sustainable Minds has a pretty low learning curve. They can jump in within that first day. They're able to start to utilize the software and get the results necessary for their analysis. Context is necessary to really understand what the LCA results mean. And then there's always discussion of trade-offs, and this could be trade-offs for performance and function as well as environmental trade-offs. And that the LCA, the actual tool that we're using, is not the entire picture, but it's a piece of the thinking of your product, not just the analysis from the LCA itself. All right, the second project that we did, again, was based off of some of Sustainable Minds materials that they have, and it was the Toasters project. So this was similar in that we gave the students several different firms that had different designs, eco designs, and then we had the purchaser, right, the users who wanted certain things out of the toaster. So we asked them to run the LCAs, read the case studies, and then recommend which would be the one that they would go for, which one they would purchase. And in this, we introduced a really complex network of transportation options so that they could see as different materials changed, how that affected the transportation and the environmental performance of the toasters. So one interesting thing that we did with this exercise is, as the students were familiar with the case studies and the different eco designs that they were going to analyze, before they actually ran the software, we asked them to write a short paragraph or two about which one they thought would perform the best in terms of sustainability. And we called this their sustainability intuition. And most of the students go in and they read the studies and the context of the designs that we give them, and they feel pretty confident that, oh, based on this, I think this certain toaster design will be the most sustainable. And then they try and defend it without having any quantitative information about it at all. So we call this use your sustainability intuition to really guess which one is going to be the best in the end. And as it turns out, almost nobody picks the correct one. So that serves as a point of emphasis that sustainability needs metrics that we can point to. And that is the value of the LCAs, because they can give us numbers that are grounded in science, grounded in engineering, and provide a common language for us to point to on why do we think this would be sustainable? If we change this option in our toaster to another material, or if we selected another manufacturer in another area, what are these impacts for our transportation? What are the impacts for end of life? Can you recycle these materials more or less? So it gave us a common ground and really highlighted the importance of quantitative information. So this is a snapshot from one of the students' results. And again, we can see that Sustainable Minds has put the results in a very simplified manner. And as it turns out, the case study that we gave them, the performance were very similar. And then the students recommended which toasters they would go for. So this exercise gave our students a deeper dive into Sustainable Minds, in which all four categories, manufacturing, use, transportation, and end of life, were all considered. And that the first part of their sustainability intuition was not really reliable. The metrics, the actual LCA results, are important. One of the company goals that we wrote in the context of this kind of canned case study was that the users wanted nothing to go to a landfill. They wanted everything recycled. And so they had to fit that consideration into their recommendation based on the different designs that we had. So it's kind of similar to the hospital gown example that we started off with, so that they fit the LCA results and the designs into the broader context of users, as well as environmental performance. All right, and the third study was really just a challenge for our EMBA students. And this is also something that we do similar for our engineering class, but it's a little bit simplified for our School of Management students. But this is where they are provided an environmental challenge on a product and asked to improve or rethink the approach to develop ideas on a new product, then to use LCA to guide their design, and then to go into the makerspace and actually build a prototype, and then give us some kind of sustainability information about it, and then pitch it to the class and to experts. So the challenge, they have 1 week to think about it, and then they go in and they have about 4 hours to finish their initial ideas about what direction they'll go, and then start to build the prototype, finish the prototype, and pitch it to us. So they do it very quickly. So it's a 4-hour thing with about a week knowing what the challenge is ahead of time. And the challenge is thinking about when you go buy hot tea at a retailer, oftentimes, maybe not so much now, but certainly in the past, when you buy hot tea, it comes in 2 cups, like a double cup, plus the lid, and sometimes with a sleeve. So we asked them, look at all these simple materials. It's 2 cups, it's a sleeve, and the top. Can you think of a better way to deliver tea so that the function and the performance and the convenience for tea drinkers is still there, and how to deal with the tea bag, and use LCAs as you're thinking about what materials, different designs, different ways of delivering tea on the go, and then build that prototype out. All right, so the key thing here is that we do constrain them somewhat. We do ask that the designs are strictly for tea drinkers who are out and about, who will not adopt any kind of permanent solution like a tumbler, or who are not in the tea or coffee shops that would go for like a ceramic mug. These are for people that want to grab a cup of tea, drink it on the go, and then quickly get rid of the container that the tea was in. And this is really exciting for our students, and it's really great to see how they can get their ideas, use the software to start to pick materials. A lot of questions start to come out, especially from our management students, about different functionality of materials, and so we simplify that and we help them. In our engineering class, they really take deep dives in the materials, especially to identify which materials would be better and have a better environmental performance. So what you're seeing here is just some sketches that our students have done along the way about different ways to deal with the cup and the expended tea bag once the tea user wants to stop brewing their tea. And of course, a few pics of our students thinking about and building their prototypes in our makerspace. These are our EMBA students. And what you're not seeing here on your screen is as they're doing the process towards product iterations, they are also jumping on their computers and quickly inputting information in Sustainable Minds so they can get immediate feedback on if they think their decisions for materials and manufacturing are worthwhile, as well as the end of life. And another picture, this guy in particular was pretty nervous about entering the makerspace, but towards the end, he was in there cutting and sawing and doing all kinds of stuff. All right, so some results. Generally, we get some kind of convergence about not using 2 cups, of using only a single cup, or using different materials for a single cup, and then to somehow modify the lid to account for the spent tea bag. So most of it converges towards this type of idea. In general, our highest impact categories were materials and then end of life. But really, for the pedagogy of this exercise, it's that life cycle thinking can really catalyze innovation and lead to directions in the design process that people wouldn't normally consider. And this is helpful for our engineering students, but also helpful for our school of management students, because while they may not necessarily be doing the actual design, this exercise allows them to have a common language with their designers on ways to think about innovation and ways to think about green product design. So that experiential learning, that hands-on, is really invaluable to them. And we've been doing this class for 3 years now. And so now I've had enough time where people have circled back to me and really said, you know, it was a fun exercise. It was a fun class at the time. I really enjoyed it, but they didn't really understand how much it would help them afterwards to really identify different ways of designing and picking different products based on LCA results, and being able to generate informed questions or informed concerns, or really informed ways of thinking about life cycle design and life cycle thinking. So that hands-on is really important, especially for our SOM people. Terry talked about this. This is kind of our big thing as well, is as you're doing product design, in the red line is what you're committing for your cost, and the blue line is what you're actually incurring in terms of cost. And this is the timeline on the bottom x-axis about designing, doing more detailed making, and then using and disposing it. But this is analogous to environmental impact. As you're designing, what you commit to the environmental impact is immediate and very quick at the beginning of the design. So this is what we talk about in terms of using life cycle thinking for innovation and for real product design, especially for engineering and micro manufacturing concerns, but also as a key language for our executives to understand when LCAs can be used early on in the design process. So the key takeaways of incorporating Sustainable Minds for the SOM class is that the learning curve is very low, and the LCA tool is invaluable for them to have a common language across the board for sustainability. Eco-design in the product development and analysis is important, especially early, and that it can help catalyze their innovation. Executives are much more readily available to communicate and more comfortable to communicate about thinking about green design and interpreting LCA information, and being able to identify strengths and weaknesses of different design options. And so this hands-on tool is great across all knowledge bases, from our engineering class, which is multidisciplinary, as well as our SOM class, who really don't have any engineers, but are able to take this on and give them a deep understanding of how to approach product design and LCAs with lifecycle thinking. And I think with that, that's the end of my slides here.
Thank you, Thomas. Seeing that story a second time, I'm even more impressed with what you've been doing at Yale and what Yale has been incorporating into their curriculum. And I think, one of the key points, particularly for people on the call to take away from Thomas's story, is that they're not expecting the people in this program to go back to their jobs and be the ones doing the hands-on modeling in Sustainable Minds and driving those decisions. Some of them may be. The bigger point is that they now understand how to integrate lifecycle thinking and LCA into the product development process. So they know how to ask for it. They know when they do LCA, what to look for, and how to use those results to drive back into decision making. That knowledge is invaluable in terms of what both Thomas and I showed in terms of the product development and cost curve, as well as the ROI from a value creation and cost reduction standpoint. Very quickly, I'm going to run through a couple of use cases. Thomas showed some very simple projects, but Sustainable Minds can be used on any kind of product, any physical product, manufactured product other than food. It is not designed to be used for food products, and that's simply because we don't have a food data set in the database. It's designed for mechanical products and building products. So the primary use case is to benchmark existing products, packaging, subassemblies, and parts to identify where in the life cycle the greatest impacts are occurring, what's causing them, and where real improvements can be made. The purpose for doing that is to drive innovation in R&D, setting environmental performance targets for products and product categories. This is really relevant for manufacturers who are doing customer-facing environmental reporting, setting performance targets for improvement, being able to respond to customer requests when you're doing private labeling and product lines for particular providers, to be able to demonstrate that improvement. And again, this influencing the external reporting ties to the performance targets, particularly now that it's increasingly important to be able to tell a continuous improvement story. How are you going to do that? The other use cases, Sustainable Minds has been used to analyze the feasibility of logistics and packaging reuse. It's a complex scenario. It's been used to win new business. So when a manufacturer does contract manufacturing to integrate using Sustainable Minds in the design of products that are being manufactured for their customers to demonstrate environmental performance improvement, visualizing environmental performance data. That's amazingly interesting. We had a webinar where one of the instructors at MCAD taught a course where she used it for this purpose. And then finally, really the use case we're talking about here, which is to develop processes in the organization to integrate lifecycle thinking into action. And, I don't want you to think that, for example, Thomas's projects were too simple. You have to walk before you can run. You have to start simple before you can necessarily attack the most complex of problems. But it's super easy to get up and running. I'm going to show you how to do that next. here are a couple of the customer stories to illustrate those use cases. And you can see this template, Thomas used our reporting template to report his results because it's really important to evaluate everything that's been done. So who in the organization did the work? What problem were they setting out to solve? So like any study, you have to define the problem. What are we trying to learn? If you don't state what you're trying to learn up front, then you don't know when you've learned it. What stage is the problem being investigated in? What were the actual results? What were the decisions made from those results? How much time did it take to do it all? Which eco-design strategies were used? And the key learnings that came out of the team. And we do this with every project that we work on with an organization, and also teach people in the organization to analyze their results in this way. This was from a number of years ago. A carpet manufacturer was looking to understand which product in their current line of products could they credibly turn into a higher performance, greener product. The most of the time that it took was to gather some data about the products, but this half day of work ended up saving them 3 months of time that they normally would have had to go through to put together the feasibility studies to come to the same conclusion. So it was a really powerful learning. This one was about the packaging and reuse. And what's important to look at is, if what you're trying to learn up front is about the carbon footprint, then you have to say that, because you want to look at the carbon footprint results, but you also want to look at the total impacts of which the carbon footprint is part of. And you want to be looking at both, because if you only solve a problem for one impact factor, one impact category, you could be creating unintended consequences in other ones. So you want to be looking at both and ultimately making the best informed decision. This was one of the use cases from a while back. Spartec, plastics processing manufacturer, making all kinds of products from plastic, built a big design center, integrated the use of Sustainable Minds into all of their new product design. We added 75 new thermoplastics and additives so they could use it for all of the products that they were working on. And we also worked with them to reach out to manufacturers in their supply chain of those materials to get data to add to Sustainable Minds. They could be modeling with accurate data. And we also introduced to those manufacturers who wanted to differentiate their materials from generic materials an opportunity to brand data within the selector to create preference for their branded version of that particular product. And those of you who are on the call who are familiar with our transparency reports can see this branded data sheet is in that family of transparency reporting products. This was part of a training that we did at Midmark, a healthcare furniture manufacturer, and they wanted to understand what was going to need to happen in terms of selecting suppliers and managing their PLM and PDM system to report on data, and figure out how their bill of materials and those tools would align with the environmental reporting tools, and figure out kind of the best way to model ultimately. What you're seeing here are some screenshots from this project, and all the text that you're seeing in italic is the annotation, the note-taking that user can do in the process of modeling to be able to track what the thinking was and what they're looking to learn. This is a shared and collaborative tool, so being able to share those questions. And ultimately, here were the takeaways. Modeling based on total weight was the same as modeling with each input. There were too many ingredients. So this worked out well. It was a good study, and they were able to move forward with modeling in a more simplified way. And they were able to figure out that the top 4 materials creating the greatest impacts created impacts both, the greatest impacts both in total impacts as well as carbon footprint. So to wrap it up, here's the range of services and software options. We call them our Getting Started programs, and manufacturers get to start where they are. We've created these services for particular scenarios. One is just a proof of concept. One is actually benchmarking products for you, so you can move your team forward. Another is a pilot project where we work with you to train your trainers, get your organization essentially organized and getting started with being a core group that can be doing this modeling and training and rollout through the organization. We also work with organizations to kind of do a larger strategy. Really, the pilot program, training the trainer, creating super users, getting a whole process in place is the outgrowth of this, which is our really our flagship training. It's one day. We can deliver it online or on site. It's in 2 modules. The morning is a tutorial on eco-design and LCA. The afternoon is a hands-on collaborative project, starting with benchmarking an example product, or we can pick a product from the manufacturer's organization. We tend to prefer the example project because it's not tied to that company's business and they can be more creative. And in one day, it's an immersive tutorial on eco-design and LCA, and really doing what Thomas showed over the course of a better part of a semester, really intensive and immersive in one day. And coming out of that is the evaluation of how does the organization take that forward. We offer all kinds of help once you're using the software. I jumped over that. We sell single-user, multi-user packages. We sell for the department or the division. You can have your own private data set that is segmented off from the public data set. We work with you to do any data creation that you might need specific to modeling your products, and then add it to the data set as needed. And so, now in summary, Sustainable Minds helps manufacturers through software and services to design greener products and to market those greener products. Product innovation is complicated and risky. We've been helping manufacturers in industry and educators all around the world for a decade now, help teach people to think from a life cycle perspective and make decisions from that same perspective. So we're pretty close to the top of the hour. I think some questions came in. Peter, are there some burning questions that we might take right now that folks would benefit from?
There were actually 2 questions asked, and they were asked fairly early in the presentation, and both of them were addressed later in the presentation. So I'm not really sure if there's still questions, but one was, does the software work for service-oriented solutions as well as products? I think we addressed that in later in the presentation, saying that it doesn't really, that it's really designed for manufactured products. And then the second question was, does Sustainable Minds also help with environmental footprint and trade-offs for internal operations?
Yeah, so the first question, it depends on the process. So Peter's right, the software models products, but if you look at a product system, and we showed the example of logistics and reuse, that is a process. So the answer, and actually the answer in LCA is always, it depends. And yes, of course, this is footprinting in a rapid way. So thanks, Peter, and thank you, Thomas, for sharing that story. What I want to let people know is that the training that we offer, Thomas will be delivering that training with us on your request. He's available. And so on your way out, we've left some questions for you to answer. You can let us know if you're interested in speaking to us about the needs of your organization, how to help you kind of get your arms around how you might get started from the most simple way to how might that scale. And I want to thank you all for attending today, and we hope you have a great day. Thanks, Thomas, and thank Peter.
Thank you, everybody.